Draw the shear and moment diagrams for each of the member. To begin, I'm going to convert my point along member AB into its horizontal and vertical components. This is going to be 6, 8. After finding the horizontal and vertical components, I'm going to proceed to convert distributor load into point load. After that, I'm going to look for external reaction forces along the points A and D, taking moment along the point. About the point A, I get a solution for dy as 14.5 kilonewton. Pardon me, it's not a kilonewton, it's not metric, it's imperial, so it's going to be 14.5 K or 14.5 thousand pounds. And value for AX or horizontal A comes up to be 9.6 K, and summing the forces in y direction, I get the value of AY as 16.7 K. After finding all the values, now I have to solve for individual members AB, BC, and CD in order to draw their shear and moment diagrams. Going to begin with member AB. Looking at our member at an angle, we know we'll have to look for A prime and B prime once we found the values of the forces at point B. By summing the forces in y direction, I get the value of By as negative 9.5 K. Summing the forces in extraction, I get the value of Bx as 0. Taking moment about the point B, I get a solution for moment B for member AB as negative 117 K foot. And now I can convert the values for the vectors at B and A into A and B primes in order to plot them on moment and shear diagrams. We know the angle for member AB is angle theta, which is 53.13 degrees, and our A prime, if we redraw it with respect to our AX, it's going to look something like this. And then if AY is drawn with respect to that, it's going to look something similar to this, where angle theta will be here. To find the value of the A prime, we have to first convert our AX to the same direction as AY, so which in this case is going to be 9.6 K, value of AX times cos 53.13 degrees. And then another positive will be converting our AY into the same direction as A prime, and this is going to be 16.7 K times cos 53.13 degrees. All in this, we get our solution for A prime as 17.7 K. Similarly, we're going to find our solution for By or B prime, and B prime comes up to be negative 5.7 K. All required values for member AB has been found. Now we can proceed to member BC. Now member BC, we know there isn't going to be any horizontal forces, so we don't have to include that in our free body diagram. The forces in the direction of CY we get the solution for CY as 14.5K. Solving for moment C by taking moment above the point C, we get our solution as 87K foot. All required forces for member BC have been found. Can proceed to member CD. We have already got all the required forces for member CD. The only thing we have to find is forces perpendicular to this member, which I've named them as C prime and D prime. Converting the load of CY into C prime, get the value as 8.7. And because it's going downwards, it's going to be negative. Similarly, the value of D prime is going to be opposite of C prime. In this case, it's going to be positive 8.7K. Now for the final part of this problem, shear and moment diagrams. Beginning at member AB, our shear is going to be our value of A prime, initial value of the shear, which in this case is 17.17. After this, nothing's going to happen for the next 5 feet. And we also have to recognize here that length of the member AB is 10 feet. And at 5 feet, you're going to get pushed down by 12 kilonewton. And we're going to come down to 5.7K. And then again, nothing's going to happen for next 5 feet. At this point, B prime, which is negative 5.7K, going to bring us down all the way to 0. This means if we are at 0, the end of the member, this means this graph is correct. Now we can proceed to member BC. And member BC, the initial value of PY is positive 9.5. Because we have a negative sign and then we have a negative value of the value for BY. Negative is positive. And then we have distributed load along this member. So we're going to go downwards 24K from 9.5, which is going to bring us all the way down to negative 14.5 over the distance of 12 foot. From here, CY, which is positive 14.5, going to bring us up to 0 mark. This means this segment is correct as well. And then for the next segment, we have our C prime, which is negative 8.7. I'm going to draw this in different colors so that we can see it clearly. We're going to come down to negative 8.7. Then nothing's going to happen for the next 10 feet until we reach point D, where we're going to have positive 8.7 D prime, going to bring us up to 0 mark, which means this section of our equation is correct as well. And because we're going to use graphical method for this problem, I'll show you a neat trick to find the intersection for our member BC here. So for a moment, we're going to begin with 0 moment for member AB. After that, we have this positive area for the 5 foot. It's going to be 5.7 times 5, which is going to be 17.7 times 5, not the other way, which is going to be 88.5. And curve is going to be first order. After that, we have next area, which is 5.7K for next 5 feet. And this is going to be 28.5. And our peak for this section is going to be 77. And at this mark, we have force MB. Correction, I said 177, it's 117. And then we have our force or moment B, which is negative 77. It's going to bring us all the way down to 0. Now, once again, I'm going to switch color to differentiate. For member BC, we have a moment B, which is going to be clockwise in this case, so 117 positive. And then we have our shear. And to find, first of all, our shear intersection, simply going to be 24 divided by 2 gives us 2, and then 9.5K divided by 2 gives us 4.75K. And that's our point of intersection. Now we can simply take area of triangle, 0.5 times 9.5 times 4.75, and this will get us to 117 plus 22.5, 139.562, rounding it up will be 3, and this curve is going to be second order, and it's going to be concaving downwards. Then we have this negative area, which is going to be negative half times 14.5 times 12 take away 4.75. Yeah, in that area, we get solution as 52.56, and subtracting from 139.56, get our solution as 87. This curve is going to concave downwards again, and in there we have our moment MC, which is counterclockwise, therefore going to go downwards. We're going to come down to 0. This means this graph is correct as well. Now to our next section, we have moment C, which is clockwise, so we're going to go upwards again, 87. And then we have our rectangular negative area, which is negative 8.7 times 10, gives us 87. So along the distance of 12 feet, you're going to get negative 87, and our curve is going to be first order curve. And since we are 0, this means this graph